Now we have come with another problem. In this problem, we will determine the fold geometry from interlimb angle and fold axis. When we know the interlimb angle of a fold and know the orientation of the fold axis, how we can reconstruct the fold geometry. The question states that the line of intersection of the axial plane of a symmetrical overturned fold on one of its limbs striking 48 degrees plunges 28 degree towards 40 degree, while the interlimb angle is 40 degree. Find out the orientation of the axial plane and the limbs. So, clearly the line of intersection of the axial plane on one of its limbs gives us the fold axis. So, we have given the information that the fold axis plunges 28 degree towards 40 degree and one of the limbs strike 48 degrees, while the interlimb angle is 40 degree and the fold is a symmetrical overturned fold. So, with these informations in mind, we will try to determine the orientation of the axial plane and the limbs of the fold. So, we again will use the tool Stereonet to determine the orientation of the axial plane and the limbs of the fold. So, now we will mark the fold axis. So, as I have already mentioned, the line of intersection on axial plane and one of the limbs gives us the fold axis. The fold axis orientation is 28 degree the plunge amount and the direction is 40 degree. So, first we will mark the 40 degree, which is this point in the Stereonet. So, this 40 degree we, as we have done in the previous problems, we will take it in the east west section and then mark the 28 degree, which is the plunge amount. So, this is the 28 degree point. So, clearly this point as I have marked is the fold axis. Now, from the fold axis we know if we go 90 degrees from fold axis, we will get the profile plane. So, 90 degrees from this point, the great circle corresponding 90 degrees from this point will give us the profile plane of the fold. So, clearly this is 2 degrees and this would be 62 degrees because we have come 28 degree from this side. So, this is 62 degrees. So, we will count 28 degrees from the center. So, this is 10, this is 20, this is 28 and this great circle will be the profile plane of the fold. So, I mark the profile plane of the fold. Now, I again rotate back the tracing paper to its original position. Now, we have another information that one of the limbs strikes 48 degree. So, we mark the 48 degree which is here. Clearly, the limb will pass through the fold axis because the intersection of two limbs gives us fold axis. So, the limb should pass through the fold axis. So, as one of the strikes of the limb is 48 degree and we have the fold axis. So, the great circle that has a strike of 48 degree and passes through the fold axis will correspond to one of the limbs of the fold. So, now we construct that great circle. Clearly, this is the other end of the strike and this is the dip angle. So, the dip angle is 6, 16, 26, 26, 36, 46, 56, 66, 76. So, the dip angle is 76 degrees and the strike is 200, 210, 220, 228. So, the orientation of limb 1 is 228 degrees and the dip angle is 76 degree. Now, what we will do is that we will bring the fold axis on the east west plane and the profile plane we will calculate the interlimb angle which is mentioned as 40 degrees. So, we have brought the fold axis on the east west plane and now we have to calculate the interlimb angle. The interlimb angle is 40 degrees. So, now it is a dilemma so we will calculate the interlimb angle in this side or again in this side. So, again we have to think of the geometry of the fold which is given in the problem and we have to visualize it. So, it is mentioned that the fold is a symmetrical overturned fold. So, now from the properties of symmetrical overturned fold we know that in an overturned fold axial plane of the fold and the two limbs dip in the same direction. So, now if we calculate 40 degree from here, clearly we will find a point and the point that one of the points of the great circle that corresponds to another limb and this fold axis would be the other point. So, if we join this we will get the limb, but if we count 40 degrees from here the point we will get the two limbs will dip in two opposite directions. So, what we will do is that we will do not count the interlimb angle 40 degrees from here, but if we count the interlimb angle 40 degrees from here we will get a point and if we join that point and this fold axis through a great circle we will get and the orientation of the other limb and the other limb will dip in the same direction as limb 1. So, the fold will correspond to a symmetrical overturned fold. So, as in the question it is mentioned the fold is a symmetrical overturned fold. So, we will count the interlimb angle in this side. So, by this way we do and visualize the problems, the geometries of the fold and then try to solve it via the Stereonet. Now, I count the 40 degrees in this plane. So, this is 4 degrees. So, this is 14 degrees, this is 24 degrees, this is 34 degrees and this is 36, 38, 40. So, this is the point. So, if I join this point and the fold axis clearly I would get the other limb. Now, I try to bring these 2 points on a great circle so that I can have the orientation of the other limb. We have come to the great circle that connects the fold axis, the other limb. And we will also mark the dip. So, the dip comes out to be 2, 12, 22, 32, 42. So, the value of dip is 42 and we mark these two ends of the strike and rotate the tracing paper to the original position. Now, when we come to the original position, we see that the strike of the limb is, so if this is 180 degree, this is 200, 210, 220, 230, 40, 50, 254 degrees. So, the limb 2, the orientation is 200 and I again count, this is 230, 240, 250, 254 degrees and the true dip amount is 42 degrees. Now, what in order to construct the axial plane, what we have to do is that we have to bisect the interlimb angle. Now, in order to bisect the interlimb angle, we bring the profile plane to the north south and we calculate the interlimb angle. We know the interlimb angle as it mentioned in the problem that it is 40 degrees. So, the bisection would be 20 degree. So, we calculate the points. So, we start it from this or this end, each will be same. So, this is 2, this is 14, this is 16, 18, 20. So, this is probably the bisection point. And again if we join this point and the fold axis, we would get the orientation of the axial plane. So, we do it similarly, we find the great circle that joins the fold axis and the bisection of the interlimb angle. Probably, not probably, certainly this is the plane. So, we draw the great circle that corresponds to the axial plane of the fold. So, this is one of the strikes of the axial plane. This again would be one of the strikes. And now, in the east west section, we calculate the tip of the axial plane. Now, dip of the axial plane is, this is 8, 18, 28, 38, 48, 58. So, the dip of the axial plane is 58 degrees. So, now I rotate, take the tracing paper to its original position and now I find the strike of our axial plane. So, if this is 180, this is 200, 210, 220, 230. So, the axial plane and strike is 239 degree and the dip amount is 58 degrees. So, when we have an fold geometry and the data of interlimb angle and the fold axis, we can reconstruct the fold geometry. So, we have that found out the orientation of the two limbs as well as the axial plane.